Good morning. Welcome to class 29. Today is our third of 3 days on operations on algebraic fractions. Let's jump in. In this lesson, we continue multiplying, dividing, adding, and subtracting algebraic fractions. We use the same process we used in our previous lessons. Number 1, we refresh our memories on how to add and subtract algebraic fractions. With this example, we'll write our final answer as a single reduced fractions. Always factor the denominators as the first step. All right. So in this case, we have 3 fractions, 2 of which are being subtracted from the first. Factoring the denominators is always our first step for addition and subtraction of fractions. So let's give that a shot. The first denominator is a 2x plus 8. And our first kind of factoring to always look for is to pull out the greatest common factor. In this case, that's a 2. And we're left with an x plus 4. So that one's factored. I'm going to leave a little bit of space on this fraction. Minus, I've got a 2 in the top, 5x minus 15. Again, always look for the greatest common factor first. In this case, it's a 5. And again, we'll leave a little space there. Copy the 2 on top. All right, in the last denominator, the greatest common factor is 1, so nothing to do there. It's definitely not a difference of 2 squares, so you try the box method. I'm not going to show the details of the box method, but if you do the box method, you will get x plus 4 times x minus 3. So take your time there doing the box method, and we'll leave a little space. Okay, the goal is to make these denominators exactly the same, and so we are going to fill in what's missing. So let's start by making this denominator and this denominator match. What does this first one need? Well, it needs a 5 and it needs an x minus 3, so let's give it both. Times 5 times x minus 3. But if you multiply the bottom of a fraction by something, you need to immediately multiply the top of the fraction by the same something. And now let's go ahead and make the second denominator match the first. So currently we have a 5 and an x minus 3, but we don't have either a 2 or an x plus 4. So let's give the second fraction both of those things, 2 x plus 4, and then immediately multiply the top by the same thing. Okay, and then we look at the last fraction. Now the first 2 denominators are the same, right? Like this matches exactly with that, just a different order, but that's okay. And now all we have to do is make the last fraction match either of the first 2 fractions because the first 2 denominators are the same. So look, this one here has an x plus 4. We've got that already. It's got an x minus 3. We've got that already. What we don't have is a 2 or a 5. So that's what we need to put right over here. So we're going to multiply right down here by 2 and 5. And the same exact thing on the top. And if you look carefully, you will notice that all 3 denominators are exactly the same. The factors are written in different orders, but that's all right. And so next thing to do is to distribute in the numerators. So let's distribute first in that first numerator. So we go 15 times x minus 3, because that's not a distributing, that's just multiplying those 2 together. And I'm going to clean up the denominator here. I'll just put the 2 and the 5 together and make it 10. But don't distribute the x plus 4x minus 3. Minus, okay, next one, 2 times 2, that's 4, which is going to get distributed to the x plus 4. Now I'm going to start writing my denominators in the same order because they are all equal to each other. And then minus the last one, 2 times 5, that's 20. Okay, so let's go ahead and distribute in these first 2 numerators. So we get 15, in fact, yeah, okay, so we'll distribute. So we go 15x minus 45 divided by the, I'm just going to start writing LCD, minus 4x plus 16, that's distributing the 4, minus 20 over the LCD. And because they have the same exact denominator, now we're in a position to make a single fraction with the LCD, which I'll write out now. And so we'll put 15x minus 45 minus 4x plus 16 minus 20. And then we're really close to being done. Problem is, we made a mistake, and it's a fatal mistake here. It looks like I've just faithfully copied all of those numerators from the three different fractions into our now single combined fraction. But the subtraction signs here, this subtraction was saying you are subtracting the entire fraction, and this subtraction says you're subtracting the entire fraction. But if we look at what we've done over here, we have subtracted the 4x, that was correct. But then we added 16. We were supposed to subtract this entire bag of stuff, and we didn't subtract that 16. So just put parentheses as part of the process every time we add and subtract fractions. And this one step right here, that's the key. It's the most common place to make a mistake. Okay, so now we are ready to distribute those minus signs through. So 15x minus 45, distribute the minus sign, minus 4x minus 16, and then there's a minus 20. I'll be lazy one last time here, LCD equals, okay, so now we combine like terms. I see 15x and I see 4x, and they're subtracted, so that's 11x. And then we've got lots of constants floating around, minus 45, minus 16, minus 20. Let's see, 60, I think that's 81. Hopefully I've got that right. And because this is my final answer, I'm going to write the denominator out. And like I said before, don't ever bother distributing downstairs at any point for these problems. So 11x minus 81 equals 10 times x plus 4 times x minus 3. Now this one turns out to be done, but actually technically there's one more step we have to look for, and that's to see if we can reduce anything on the top with anything on the bottom. So the top is a subtraction, so we can't cancel anything when there's addition or subtraction. So you look to see if you can factor out a greatest common factor from the top. Now we can't in this case. The greatest common factor upstairs is 1, so there's nothing to do. But for example, suppose that you could factor a 10 out of both of these things. And so suppose it turned out to be 10 times some stuff when you factor out the 10. Well, then you could cancel the 10s, right? So this is why we do need to look just to see if maybe we can cancel something. But we looked, and in this case, we can't do any factoring, so we can't cancel anything. So that's our final answer. Okay, number 2. Let's try this one. Writing our final answer as a single reduced fraction. Note that it is tempting but entirely unnecessary to find the lowest common denominator. Well, let's see why. So in this case, we've got a multiplication and we've got a division. Definitely very different from an addition or subtraction problem. So let's see what we can do. So the first step, when I see division anyway, is to copy the first thing and change division to multiplication and flip the second thing. So that's what we're going to do. So copy that thing. This 3x to the 7, I'm thinking of that as my first thing in the division problem. Division becomes multiplication, and then you flip the thing after the division sign. So this first step is just lots of copying. Okay, now that it's all multiplication, I'm happier. And the idea here is to factor everything, not just the denominators like we did in the subtraction problem up above, but factor everything, numerators too. So here we go. 6 things to inspect and see if we can factor. First fraction. First technique on the top is the greatest common factor. It's 4. We're left with x plus 3. On the bottom, greatest common factor. Don't be intimidated by x to the 4th. Always look for the greatest common factor first. So in this case, you can pull a 9 out of both and an x to the 3rd out of both. And we're left with x minus 5. Okay, times 3x to the 7th. Nothing to do there. That's just a single term. No factoring. X plus 7, well, that's 2 terms, but greatest common factor is 1. It's not a difference of 2 squares. It is certainly not a box, so there's nothing to do with either parts of that fraction. But I think there's going to be things to do with both parts of the next fraction. So upstairs, I see 3 terms. It sure looks and feels like a box to me, so do the box. But again, we're not going to show the details here, but it turns out to be x plus 7, x minus 5 after you do the box. And then downstairs, we're going to factor out the greatest common factor. It looks like it's 7, and 7 is a common factor, but 14 is actually better. 14 goes into both of these. And we're left with x plus 3. Okay, now that we've got everything in factored form, avoid the temptation to try to build the lowest common denominator. It is not necessary and makes the problem way, way, way more complicated than it should be. For multiplication and division, we don't need any least common denominators. We just cancel whatever we can from top and bottom in any pair of fractions, and then we'll multiply straight across at the end. So all I'm looking for right now, something on the top which reduces with something on the bottom. So for example, I see a 4 up here, and I ask myself, is there anything I can cancel with? Well, 4 does not cancel with the 9, but 4 partially cancels with the 14, so that's where I go first. Both of them are divisible by 2. So let's go ahead and get rid of that 2 in both of them. 2 there, 7 there. Next thing I see on the top here is an x plus 3. I'm looking on the bottom. No, not there, not there. Hey, there's a winner. So we cross off the x plus 3's in both. Moving right along on the top, I see a 3 up here. I'm looking for numbers that will cancel. I can cancel partially the 3 with the 9, so let us do that. 3 goes away. I'll put the 1, but you don't need it. Divide this guy by 3, and it becomes 3. Okay, next up I see here x to the 7th. I'm looking for any free floating x's on the bottom. There are some right there. We know that we're supposed to subtract the powers in this case, so we will combine, we will cancel. And this guy becomes x to the, let's see, it was 3 on the bottom, so I guess that's x to the 4th left over. And this one cancels entirely. All of the x's are left on top here. Okay, continuing on the top, I see an x plus 7. Does not match there. It does match there. Let's get rid of it. X plus 7 here. X plus 7 here. If you want a placeholder, you can put a 1 there. And then finally, x minus 5 on the top matches nicely with this x minus 5 right here. So let's get rid of both. Okay, and if you have gone through everything on the top, which was our process here, right? We just kind of went along this way, then you're done. You don't even have to like check to see if there's other stuff left on the bottom. It makes no difference. We've taken care of everything on the top, so we've taken care of everything. So now it is just a matter of carefully reading what is left in this mess here. Okay, on the far left there, I see an orange 2. In the middle fraction, I see a green 1. I'm not going to copy that. Then I see a black x to the 4th. I will copy that. And in the last fraction in the numerator, there's nothing left over except a 1, which I won't write. Divided by. Denominators now. First fraction, I see a 3. Second fraction, I see a 1. I'm not going to write it. Third fraction, I see a 7. These were all multiplication. These fractions are being multiplied, and we're multiplying straight across in these fractions. So the only thing left to do is smush together the 3 and the 7. And that's it for multiplication of fractions. If we've done the process correctly, we don't need to look here and say, hey, is there anything to reduce? No, we've done all of our reducing first. So it's different from the addition subtraction where we had to see, hey, can I cancel anything from the top and the bottom? If you do this multiplication process right, you will never have anything left to cancel. You've canceled everything possible. Okay, jump into the activity and I will walk around and answer questions.